Imagine savoring a bowl of exquisite fish soup in an upscale restaurant, the flavors tantalizing your senses. The restaurant's diligent staff arose early to secure the freshest ocean harvest from the fish market, and a master culinary chef meticulously crafted the delectable fish soup you're relishing. Yet, here's a sobering notion. What if we were to reveal that despite the careful washing, cleaning, and precise deboning of the fish, it might contain as many as 47 traces of microplastics? Each year, the average person ingests between 39,000 and 52,000 particles of microplastics, the quantity influenced by age and gender. These minuscule particles, spanning from 1 micrometer to 5 millimeters in size, have managed to infiltrate our bloodstream, brain, semen, and even our food. In an intriguing pilot study, researchers have now detected microplastics within heart tissues. According to the official release from the American Chemical Society, the investigators scrutinized the heart tissues of 15 individuals both before and after undergoing heart surgery. Employing advanced techniques like laser direct infrared chemical imaging and scanning electron microscopy, the team uncovered the presence of microplastics in tissue samples obtained both prior to and post-surgery. Blood samples were also collected from half of the participants, both before and after the surgical procedure. Remarkably, they identified 9 different types of microplastics in these blood samples, both pre- and post-operation, with the largest particle measuring 184 m in diameter. Interestingly, alterations were observed in the type and size distribution of microplastics within the blood samples after the surgical intervention, indicating that microplastics were introduced into the body during the surgical procedure itself. It's worth noting that not all tissue samples contained microplastics, emphasizing their uneven distribution. These minuscule particles, spanning up to 469 m in diameter, were identified across 5 distinct tissue types. Consider this: every minute, approximately 1 truckload of plastic waste is deposited into the ocean, contributing to an estimated 14 million tons of microplastics accumulating on the ocean floor. Regrettably, these figures continue to surge, despite ongoing endeavors to curtail global plastic consumption. The researchers aptly stated in their study that further research is needed to examine the impact of surgery on microplastic introduction and the potential effects of microplastics in internal organs on human health. Published in the journal Environmental Science and Technology, this study underscores the vital need for a deeper understanding of the implications of microplastics in our bodies. Study abstract. While microplastics have previously been found in human stool, lungs, and placentas, organs directly exposed to the external environment through various body cavities, the presence of microplastics in completely enclosed human organs has remained an unexplored territory. Using laser direct infrared chemical imaging and scanning electron microscopy, we investigated the presence of microplastics in human heart tissues and its surrounding structures. This investigation involved collecting microplastic samples from 15 individuals who had undergone cardiac surgery. Our findings indicated that microplastics were not uniformly present in all tissue samples. However, 9 distinct types of microplastics were discovered across 5 tissue types, with the largest particle measuring 469 m in diameter. Further detection of 9 types of microplastics in pre- and post-operative blood samples, with the largest particle at 184 m, highlighted alterations in the type and size distribution post-surgery. Importantly, the presence of polymethyl methacrylate in specific tissues could not be attributed to accidental surgical exposure, providing direct evidence of microplastics within patients undergoing cardiac surgery. This study underscores the necessity for additional research to assess the impact of surgical procedures on the introduction of microplastics and the potential consequences of these particles within internal organs on human health. Stay tuned for more insights into the world of scientific discovery and preparedness. Subscribe in our channel.